So hello students, welcome once again to our YouTube channel. I believe these sessions, these videos must be quite helpful to you people. So now, as you can see, I posted the questions earlier. Okay, so that's what I am trying to do every time, so that you people can just try those questions and then go for the solutions of those questions. Okay, so that will be a better thing. Of course, trying yourself and then looking at the solution of those questions which you couldn't solve, or maybe then you have an alternative idea also. Okay, if the methods vary, if there's a difference in the method. Okay, chaliye, let's start with the question. See, the first question is you have to evaluate the value of 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square and so on and so on to infinity. Okay, now see, I don't think we can evaluate this series as it is directly, bacho, and until unless you people know its value. Okay, because of one reason or the other, its value is pi square by 6, and so I mean value is pi square by 6, it doesn't has to do with that statement one reason or the other. I was saying because of one reason or the other, if you know its value, then also I believe that this you can evaluate without even knowing the value of this series. Okay, which is 1 plus 1 by 2 square plus 1 by 3 square, so on. So I will say, okay, I will say let's assume that we don't know its value and the value be p here. Okay, now see, the interesting and important part here is that whenever you have opposite sign for even and odd terms in a series, then you can always try to complete the series by adding and subtracting the even terms. Okay, so that's my suggestion here. So by adding and subtracting the even term, so I will write it as, so you'll be writing the complete series which you are already given here and which we have assumed as its value to be p. So I, here, since odd even terms have negative sign, so I'm adding even terms so as to complete this numerator series. So this is what we get, but since we added, of course we need to subtract, and once they are already being subtracted, the even term, so when you subtract it again, it will be minus 2 times 1 by 2 square plus 1 by 4 square plus 1 by 6 square and so on and so on. Okay, now this is p, of course we have already assumed it to be p, minus and 2. See, whenever you add and subtract the even terms, what happens is you can of course take 1 by 2 common. Here it's 1 by 2 square, 1 by 4 square, so I can take 1 by 2 square common, which is 4. So it's 1 plus 1 by 2 square, and that repeats the same series again. Okay, so which I'll be calling it as p again. So p minus p by 2, which is p by 2. So therefore the answer is p over p by 2. So that's the general method which I apply. See, I have applied this type of things, or this method, in several such type of questions. So if I will get time, and because last year also I got a very good question based on this thing only. Okay, it took some time, but I could solve that question. So if I will get back the question, that I will definitely try to share it with you people, maybe in some next other sheet of miscellaneous type of practice sheet. Okay, so now moving to the next question. So do remember this thing, bacho. Okay, now second question is the sum of this one is. So again, see, whenever we have to write or rather solve a series, or we have to evaluate a series, the first step without any fail should be to write the general term, until unless we have a standard series where we don't need, like, if it's a AP, of course, if it's a GP, we don't need to write the general term. But otherwise, I always say, if you have to solve a series, you should write the general term as the first step, and here the general term has not been given. Okay, so the general term here will be, of course, this is 3 4, where that's an AP till 2009. Okay, so the AP is what is it? It's 2r plus 1, isn't that? Starting with starting r as 1 itself, so 2r plus 1, here in denominator it's r factorial plus r plus 1 factorial plus r plus 2 factorial. I'm sorry, if it will be 2r plus 1, the common difference will be 2. So I'm really sorry, it should be rather r plus 2, isn't that? Because I didn't try to use API, I just said, but I just wrote it on the basis of the intuition. Okay, so anyways, that's what you will get. Now see, what do we need? We need the sum of such a series where the last term will be 2007. So S 2007 will be nothing but summation of TR, the general term when R goes from 1 to 2007. Isn't that fine? Now see. So now S is summation, and we have what we have in numerator R plus 2, yeah, over r factorial plus r plus 1 factorial plus r plus 2 factorial. See, one thing, the most important method in series is like breaking the general term of the series as the difference of two consecutive terms. Okay, it can be written as tr minus tr plus 1, or maybe tr plus 1 minus tr. Okay, or whatever difference of two consecutive terms. And if not in as a difference of two consecutive terms, then at least difference of two term, bachcho, difference of two term. Okay, so that's one method which I always and always use. Okay, so which I always and always use whenever I come across a series, bachcho. Fine. So whenever I come across a series which I can't solve with the help of any general method. Okay, so that's one thing I always try to use here. Okay, so see, I deliberately I've included at least I think 3 4 questions based on this method only, so that you get a fair idea of as to how to apply it in different situation. See, there's no set steps which may help you in rewriting the general term as difference of two terms. Every time we have to think. Okay, so start, like, see what's the choice we have. So of course I will take r factorial as common. See, we don't have any other choice according to me, as far as I can see here. And rather than taking the r factorial, other than taking r factorial common, so I took it out. So r plus 1, and then here we have r plus 1 into r plus 2. Fine. So again I don't have any other choice other than to simplify whatever we have in within bracket in denominator. So it's r square plus 3r plus 4r and plus 2 plus 2 4. Okay, yeah, that's it. Fine. So S is nothing but summation. R goes from 1 to, so whatever it is, R goes from 1 to 2007, R plus 2, and in denominator we got R factorial into R plus 2 whole square. So of course we will cancel it. Now what? Now what? See, I always had that thing at the back of my mind that I need to rewrite it as difference of two terms. Okay, so for that I just see there are two factors in the denominator. Rather, if one is r plus 2, one is r factorial. So we shouldn't call r factorial as a factor, but still I'm just calling it for the sake of simplifying the statement. So if we can merge them to write as a single term, how? For that I multiply both numerator and denominator by r plus 1 to rewrite the denominator as r plus 2 factorial. Now everything, all the focus comes to the numerator part. Okay, so s is nothing but summation. Now I'll be writing it as r plus 2, adding 1 and subtracting 1. I think all of you now get the idea what am I up to here. So r is equal to 1 to 2007. So r plus 2 over r plus 2 factorial minus 1 upon r plus 2 factorial. All of you agree now? Bacho? So it's r goes from 1 to 2007, and this is 1 upon r plus 1 factorial minus 1 upon r plus 2 factorial. Isn't that the difference of two consecutive terms? I think it is. है ना बच्चों? So that's the difference of two consecutive terms which we get here. Okay, so therefore now start with your r is equal to 1. So what do we get? So we get it as 1 by 2 factorial minus 1 by 3 factorial, and similarly when r is 2, so 1 by 3 factorial minus 1 by 4 factorial, and so on and so on. The first term gets cancelled as 1 by 3 factorial. That means we are going to be left over by this term. And in such type of series where we can break the general term as a difference of two terms, be very sure that the number of terms you are left with in the beginning will be same as the number of terms you will be left with at the end, and with opposite sign. So you are left with just one term in the beginning, so you'll be left with only one term at the end, and that will be with negative sign. Now this term you got when you put here the first value of r, so of course the negative term will get at the end when you put replace r by the its the highest maximum possible value here in this term. Okay, so I can write it directly as 2009 factorial without even thinking to write any more step or simplifying it further. Okay, so that's the question here. So an important question because of this step bachcho. Okay, so chaliye let's move to the next question. The nth term of the sequence is given by this one, then the product. Okay, so it's a question of the product. So see, again the same pattern. The only thing is there we break it as the difference of two terms. Here we may try to write it as the ratio. Here it's already given as a ratio, but still see, let's try to simplify. How, why am I saying it? Because it's clearly visible that both numerator and denominator are factorizable. So in numerator it is n minus 2 into n plus 1, whereas in denominator it's n into n plus 3. Okay, see, look at here very carefully, bachcho. If I write this numerator as p we have already used qn, isn't the denominator qn plus 2? All of you agree or not, bachcho? Isn't that? Replace n by n plus 2, want to get the denominator. So it's a ratio of two terms of the same sequence, but not consecutive with a gap of 1. Okay, n at term, n plus 2 at term. Now, how will it help? See, so your P is actually T3. So n is 3. So let's write it. So it will be 3 minus 2, which is 1 into 4 upon 3 into 6 into 4. So 4 will be 2 into 5 upon 4 into 7. Now see, next 3 into 6 upon uh, um, 3, 4, 5 into 8. Now see, that's what I meant to say here. Now the terms start getting cancelled. Why? There's a gap of 1. So the first term didn't get cancelled with the second factor here. The other started getting cancelled from the third. So that means these factors, now these terms will go on getting cancelled. So that means you are left with two terms as product in the numerator. So hence we will be left with two terms as the product in denominator. Okay, so we started with n is equal to 3. So n is equal to 49, n is equal to 50. These are the last two terms. So replace n by 49. And since we are going to have it in the denominator, so 49 into 52, and the last one will be, I'm not writing anything in the numerator. Okay, that's not our concern because they, in any case, they will get cancelled. So 50 into 53. So therefore, the answer is simply 2, 5, 10, and 40 over 49, 50, to 50 is 5 into 49, 7 square into 52 into 53, 4 and 13. So that's the answer. 5, 7 square, 1353. That's the answer. Okay, a similar question, but not based, since it's based on product of the terms, so hence we try to write the term, general term, as the ratio of two terms of the same sequence. Okay, now chaliye, let's move to the next question here, fourth question. See, that's not my concern. Of course, that's not our concern because that's a fixed value constant. Our concern, our whole concern should be simplifying this thing. And here I am seeing that K1 goes from 1 to 2010. It's same in both the cases. Moreover, denominator is same in both the cases. In numerator, one factor K factorial is same. So if I take it out, and then we are left with K square plus K. Isn't that, bachcho, hai na? So that's what we'll be left with. So it is like 2012 factorial upon 2 raised to the power 2010 minus. Okay, so k factorial into k plus 1 upon 2 raised to the power k. So I will say that this is a beautiful question on again the same pattern which I've been talking about since the beginning of this video, and that is rewriting the general term as the difference of consecutive terms. So k plus 1 into k factorial is k plus 1 factorial into k upon 2 raised to the power k. Now that might be a bit of challenge here. Okay, how to rewrite it as a difference of two terms? So because see, if we have 2 raised power k in one term, let's say k at term. So in the k minus 1 at term, it should be 2 raised power k minus 1 or vice versa. 2 raised power k and 2 raised power k plus 1. So the power of 2 raised this term should also vary, should also differ by 1 unit in both the terms. Okay, so keeping that thing in mind, so of course this minus summation k goes from 1 to 2010. See, what I thought was just, and one more thing, k plus 1, the next term will be k plus 2. If we have to, I mean, change this one also. So k plus 1 factorial can be either written as k plus 1 factorial minus k factorial, or the other choice is k plus 2 factorial minus k plus 1 factorial. Okay, so I added 2, I subtracted 2. Now what do we get here? So this is 2012 factorial over 2 raised power 2010 minus, so now I think all of you would have understood, k plus 2 factorial over 2 raised to the power k minus 2 times bachcho. So that 2 will get cancelled, and in numerator you have k plus 1 factorial over 2 raised power k minus 1. So if this is the kth terms, of course this is k minus 1 at term. So why I don't know why I took summation here, is not required, because in any case, yeah, then only it works simply. Okay, so that's it. Now again, you just open it out and then simplify it. I think you all will get the answer, bachcho. I believe so, isn't that so? See, the important thing is the first term will remain here, will be here is the negative term, I believe, and then the second term will be, the last term will be, that will be left with will be the positive term from here. Okay, so that you can expand, and now we all know how to do it, so we can do it. Now moving to the next question, again a similar question. I believe you all would have solved the series of inverse trigonometric function, particularly tan inverse and cot inverse, using the same method, rewriting the general term as a difference of two term. Okay, so I've selected two such questions here for you people. So this is the first one of for the series of tan inverse. So see here again. So which identity guide us? So the identity which guide us is nothing but tan inverse A minus tan inverse of B is equal to tan inverse of A minus B over 1 plus AB. Okay, so the difference of two terms. So what are we looking for here is basically this is one thing plus one, and then the remaining part in the denominator must be factorizable such that its difference should be in the numerator. So that's the guiding light for us. Okay, okay. So now again, so I'm not disturbing the numerator for the time being. In the denominator, see, of course I can write it as r raised power 4. As I said, 1 I need for sure in denominator. So that's one thing I always try to get as the first step. So r goes from 1 to 50. Now tan inverse of, see, the factor of r raised power 4 plus r square plus 1 is. So how do you do it? You add r square and then you subtract r square. Okay, so I can write it as summation over tan inverse of 2r upon. Now this is r square plus 1 whole square. So this is r square plus 1 whole square minus r square, which is a square minus b square. So now when you write it, so you got two factors as a and b in the denominator. One thing will really be interesting to see that whether difference is this numerator term or not. So what are those factors? So r square plus r, a plus b into a minus b. Now tell me, do we get numerator as a difference of this and this, a and b? Of course it is. Okay, so you can write it as r square plus r plus 1 minus r square minus r plus 1. That's it. Okay, so this is nothing but summation over tan inverse of A, which is r square plus r plus 1, minus tan inverse of B, which is r square minus r plus 1. Okay, now to finish it, see, the next step is really important. I mean, we need to check whether the terms are getting cancelled or not. So if we start with r is equal to 1, the first term which you get here is tan inverse of 3 minus tan inverse of 1 plus tan inverse of, when r is 2, Yeah, when R is 2, so 4 plus 2, 6, I think 7, minus tan inverse of when R is 2, 4, 6, 4 minus 2 plus 1 is 3, one more, tan just for myself, I am doing it, so 3 square 9 plus 3, 12, 13, minus 9, 6, 7, yeah, that's fine, it's perfectly okay. Okay, so see, 3, 3, 7, 7, 13, 13. So the first term we are left with is tan inverse of 1. The last term will be left when you replace. See, this is negative term. As I told you all earlier, that the number of terms which you are left with in the beginning, the same number of terms you will be left with at that last, but with opposite sign. So last term you will be left with will be positive sign, and that you will get, of course, the positive term you will get from here, and when you replace r by 50 here, so it will be simply this is equal to tan inverse of 50 square, which is 2500, plus 51, okay, minus tan inverse of 1, and now we can easily apply again tan inverse a minus b, and I think whatever is required here we will be able to get it. Don't forget that it's cot s, it's not tan of s, okay, so what are we going to get is actually tan s, okay, then we can convert it to the cot s form. Okay, now consider this sequence. I think few of you at least would have already seen this question somewhere or the other. Okay, see, uh, interesting one. A1 is half, an plus 1 is, actually it took lot of time for me to solve it, and it happens sometimes. I mean, sometimes you are, while solving a question, you the idea, the perfect exact idea strike your mind instantly, or maybe in a minute or two, and sometimes it takes hours. Okay, so that was a question where I have to spend, I won't say hours in a continuity, but of course in totality I would have spent at least 45, 50 minutes or maybe an hour, okay, and thinking about this question. See, what we did was take an common, and this is an plus 1. Okay, so then take the reciprocal, n plus 1th term is equal to 1 by nth term into nth term plus 1. Okay, now you can rewrite this as 1 by an minus 1 by an plus 1. Isn't that what? So now I can write 1 by an plus 1, and plus 1th term minus 1 by an as minus 1 by an plus 1, or this as this minus this. Fine. So, of course, this term, there's nothing which can take you to the negative thing. Okay, so the term is going to be positive in that case. I mean, it's an increasing AP or increasing sequence, because n plus 1 term is an square plus an. Okay, so it's of course an increasing one. So that means 1 upon an is a decreasing one. Okay, so that makes sense that this is going to be positive. So now what? So what we need is S sum. So sum will be, now go on putting the value of A1. So 1 upon A1 plus 1, 1 upon A2 plus 1, 1 upon A3 plus 1, and so on and so on. Okay, so S will be, so A1 plus 1 is from here, 1 upon A1 minus 1 upon A2 plus 1 upon A2 minus 1 upon A3, and so on and so on. See, the same pattern is here also. The alternate term get cancelled. So you are left with first term, which is 1 upon a1, which is 2. You will be left with last term at the end. And what will that be? That will be, let's say, if I try to just figure it out, a2 square, a2 rather, is 1 by 4, a1 square plus half, which is 3 by 4. And similarly, a3 will be 9 by 16 plus 3 by 4. Now, I just want to check whether um, okay, so it's still which number? Nth number. Fine. Okay, just a minute. Is it greater than 1, bacha? 16 348. Oh, sorry. 12 9 21. Yeah, it's greater than 1. So for sure, the last term will be the reciprocal of greater than 1. So it will be less than 1. Okay, so the last term will be, because from the third term onwards, you got the term which is A3, which is greater than 1. So, of course, 1 by A3 is less than 1, 1 by 4. A4 will be less than 1. It can't be negative. Okay, so last term you will be left with is the negative term. So, it will be an plus 1 at term. Okay, now this is less than 1. So, this is less than 2. So, the greatest integer of S lie between, okay, 2 and 1. So it's less than 2, and of course this is greater than 1. Okay, so greatest integer is nothing but 1. Okay, so that was again a question where all the efforts has to be put in to get it as a difference, or rather here I will say difference of two consecutive terms. Okay, so that was another term based on the similar concept. Now we have this term. Okay, so this is actually given. See, I will tell you what's the purpose here. So 1 TR is actually 1 by TR, isn't that? Okay. So we have to just find this thing here. So it's nothing but summation TR, which is n plus 1 into n plus 2 into n plus 3 into n plus 4 by 4 minus 6. Okay. Now, see how to get the Rth term from the, or and a general term from the series. So we can write TR as SR minus, all of us must be knowing it, isn't that? So when you do it, so it's R plus 1, R plus 2, R plus 3, R plus 4, and then it will be R plus 1. So you can take R plus 1, R plus 2, R plus 3 by 4 as a common, and then 6 and 6 will get cancelled, isn't that? So the SR will be having R plus 4 minus R. So, see, we got TR. R plus 1, R plus 2 into R plus 3. Now, see, if I have to, like, if I have to evaluate it, I won't go for simplifying this series and then putting the limit. Why? The reason is simple. Summation of R is n into n plus 1 by 2. If you observe one thing, it's n square by 2 plus something. Linear. And you got a quadratic. And the coefficient is that same power 2. Similarly, R square. So of course we all know n into n plus 1 into 2n plus 1 by 6. If I have to write it in polynomial form, it's n cube by 3 and then some other thing. Similarly, summation R cube is n into n plus 1 by 2 whole square. Again, if I have to write it in a polynomial form, it's n raised by 4 by 4 plus something something, whatever that be, doesn't matter here. Okay, now what am I trying to say is, see, we can easily compare the summation with the definite integral. Rather, I'm going to compare it with integral. So we all know summation of r dr. Okay, r is for n dr. R is for n plus 1 upon n plus 1. That's the simple logic here. So tr. So r into tr will be a fourth degree polynomial with leading coefficient as 1. Okay, so if we put summation here, so I'm writing it here. Summation r into tr will be a fifth degree polynomial by 5, leading coefficient as 1 by 5. Now, observe the degree of denominator. So numerator, so when we go for evaluation of this limit, see what's happening is it's infinity by infinity form, where numerator is a polynomial of degree 5, denominator is a polynomial of degree 5. So what's the answer? So answer is directly the leading coefficient of numerator, which is 1 by 5, over the leading coefficient of denominator, which is 6. So its answer is simply 1 by 30 without any further calculation. So once you have the Rth term TR, capital TR, okay, I believe we don't need to evaluate. I mean, we don't need any calculation to get the answer. Okay. So now moving to the next question. Now that's again a very interesting question. Okay. Now see, since m and n are two totally independent variables. So my point here is, will that make any difference if I replace n by m and m by n everywhere in this series? I, I think all of you agree that won't make any difference, because it doesn't matter. See, you replace n by A, M by B, and rewrite the series. Will it make any difference? Answer is no. Replace m by s, n by t. Will that make any difference in this answer? Answer is no. So similarly, if I replace interchange m and n, will that make any difference? Answer is again no. Okay, but see, interesting thing is that denominator won't change. I mean, this factor at least in the denominator won't change. Of course, this will change 3 raised power. Okay, now I will say add the given and the obtained new one by interchanging n, so you get 2s. Now see, double summation. This is same in both of them. Okay, I take mn common, you get n by 3 raised power m plus m by 3 raised power. Now divide it by mn here. What do we get? So if I take this, just a minute, that was common. Uh-oh. That's what we'll get, no? Wait. Uh, if I take this in that denominator, so this is this, this is this. Okay, fine. Oh, okay. Rather, I would have taken the, I'm sorry. Yeah, I would have taken the LCM there. That would have been it. So it's n times 3 raised power m plus m times 3 raised power mn. Take LCM in this here. So mn upon n into 3 raised power m plus m into 3 raised power n, and then after taking LCM, n into 3 raised power m plus m into 3 raised power n upon 3 raised power m into 3 raised power n. That's it. So yeah. Now we got it. So 2s is summation, double summation m by 3 raised power m into n by 3 raised power n for variable m. N is a constant for variable n. M is a constant, so I can easily write it as n upon 3 raised power n into summation m upon 3 raised power m. Okay, now or I can simply write it as summation m by, because they are altogether same, m goes from 1 to infinity. Now that's a simple, I will call it as P, a simple AGP, arithmetical geometric progression. Okay, so 1 by 3 plus 2 by 3 square plus 3 by 3 cube. And what do we need here is, so what do we do in that case? We multiply both the side of the series by the common ratio of the GP and rewrite the series on the right hand side by shifting it by one term, and then we subtract it. Since it's an infinite GP, so we don't, the last end term doesn't bother us, and then we subtract it. So we get 2p by 3 as 1 by 3 plus 1. So it's a simple infinite GP here. So it's 1 by 3 over 1 minus 1 by 3. So it's nothing but 1 by 2. So p is nothing but 3 by 4. So 2s is nothing but 3 by 4 whole square. So it's 9 by 16. So S is 9 by 32. Now look at the option. I think one option is for sure, which I remember. P plus Q is 41. So that's for sure correct. One is a perfect square, and rest of the option you can easily match with you. Now moving to the ninth question here. Uh, the question is, given that x plus y plus z is 15 and where a, x, y, z, b are in AP. So we know that sum of first and last term is equal to sum of second and second last term is equal to the middle term, twice of the middle term. So x plus z is nothing but 2y. So 3y is 15. So y is 5. Now a, x, y, z, b are in HP. Okay, so again, so that is in HP. So 1 by A, 1 by X, 1 by Y, 1 by Z, 1 by B are in AP. Acha, see, one thing is for sure, bachcho. X, Y, Z are in AP, and 1 by X, 1 by Y, 1 by Z are in AP, not possible. Okay, so it's for sure. See, these are two independent information. So don't try to relate the same X and same Y in both the places, right? Because the relation is given for X, Y, Z. Okay, the value is given for XYZ. So it would have been better rather if it would have been written here A, P, Q, R, B are in HP. Okay, so anyways, um, yeah, so from here I can write A plus B is 10, है ना? Now come to this place. So again I will write 1 by X plus 1 by Z is equal to 1 by A, because AB property of AP is equal to 2 by Y. So here again is 3 by Y is equal to 5 by 3. So Y is 9 by 5. Y is 9 by 5. Isn't that? Okay. So now, um, of course, so what does that mean? 2 by Y is 10 by 9. So which is nothing but 1 by A plus 1 by B. Now see, you have two relations over A and B. Okay. So if you talk about the geometric mean, of course, it is nothing but A plus B by AB. A plus B is 10, so 10, 10 gets cancelled. So AB is 9. Geometric mean of AB is root AB, which is 3. So this is correct. Possible value of A plus 2B is 11. That we can easily check. Okay, because A plus B is 10. And then, I mean, that you can easily find. AM of A and B is 5. Of course, A plus B. So this is also correct. HM of A and B is 9 by 5. There, so HM is nothing but, what is it? 2ab upon a plus b. Okay, so that also we have this value, so it's no, that also we can check. I think it's correct, 9 by 5. So the only thing is a plus 2b is equal to 11. So that one thing we have to check here. So can we find the value? Of course we can. See, we have ab, which is 9. We have a plus b. Okay, so 9 plus 1. Of course. So 9 plus 1 is a direct one thing which we satisfy. So a plus b, so a is 9, b is 1. So a plus 2b is 11. That is also one of the possible values. So I think all the four options are correct. But the sequence satisfy this and this and this. See, this is one question which I will say one of my student in the class solved it. I was really, I mean, thinking a lot on this question. That was a question pending for today. But one of our student, when I told my students in the class, those who are preparing for advance at the campus here, at Adi Batla campus in Turito. So when I told them, so one of the student came to me and he gave a very wonderful solution. He said, just multiply by a n plus 1 both the sides. So a n plus 2 into a n plus 1, and then bring it to the side and see, the moment you do it, you see, oh God, that's it. That was the thing. यही तो था. That's it. Again, see, difference of two terms. Difference of two terms. Okay. So then say, okay, then it's fine. So then we started with like, we are given A1 here. We are given A2 here. Bachcho. Okay. So then we started with the like sequence again. So if I put the value n as 1, so it's A3 into A2 minus A1 A2 is equal to 2. Similarly, if I write next one, A4 A3 minus A2, yeah, A3 A2 is equal to 2. Now see, the terms will start getting cancelled like this. Okay, not vertically, diagonally, they will start getting cancelled. The last term left will be, see, I have to get A 2012 here, bachcho. Okay, so A 2012 here will be the should I shouldn't breach this limit. Okay, so n plus 2 has to be 2012, so n should be 2010. So a 2012 into a 2011 minus a 2011 a 2010 should be 2 here, and this last term will also get cancelled. So when you add them, what are we left with? A 2012 minus a 2000, sorry, into a 2011 is equal to, how many terms are there? How many terms are there? So it doesn't, isn't that, oh acha, acha, wait, that will be doing it at acha, चलिए लिख ही लेते हैं. So how many terms are there? So it's 2 into 2010. Why? Because I started with n as 1. Okay, and to get 2012 here, I put 2010. So 2010. So this is A 2012 is nothing but 2 into 2010 over A 2011. Fine, bachcho. Oh, wait. And this will be left here. I mean, this term will be left here. So this will be plus 2. I'm sorry, plus 2. So it's 2 into 2011 upon A 2011. Achha, in general, what we will get? In general, we'll get an plus 2 into an plus 1 is equal to 2 times n plus 2. Okay, so an plus 2 is 2 times n plus 1 upon a n plus 1 at term. So if you see, if we want here, we need a 2012. So that's what I wrote here. 2 into 2011 by a 2011. A 2011 will be 2 into 2010 into a 2019 will be 2000 into 2009 upon a 2008 will be 2 into 2008 into and so on and so on, 2 into 2007 upon 2 into 2006. So see, there's the observation is all even terms we are going to have in the denominator. The last term will be a2, which is 2. It will be a2. Okay, and last one of course will be a1, which is 1, the numerator. So how many 2 we have? Exactly, according to me, the same number of 2 as we need, rather we have one extra 2. We have one extra 2. But wait, 2011, 10, 6, then it will be 5, 4, 3, 2, 1. Um, we don't have any extra 2 here. Why? Because see, we start with odd in the numerator, ended with odd. If this also there also would have been 1 2 here, we would have one extra 2 in numerator. Okay, so I think all 2 will get cancelled according to me. So now just put the value what in the expression. We need 2 2009 by 2011 into 2011 into 2009, 2007, 2005, so on and so over 2010 into all event into 2. Okay, we need one more 2 here. Okay, so that means there should be an extra 2, so into 2. Okay, so now see, 11 gets cancelled. Now see, if I start cancelling 1 2 every time here, so 1005, then 1004 into 1003. Where will I end up? I will end up at 1. So it's 1005 factorial. So we had 2 raised power 2010. So now I have half of them. Okay. So now finally it is 2 raised power 1005 into all odd 2009, 2007 till 1 over 1005 factorial. Isn't that 2010 C 1005? Okay, because when you cancel remaining 1005 factorial one by one from the numerator, you will for every term you will get 1 2. So 2 into 1005, that you people can simplify now. So see, for an example, if I say 8C4 simply, so 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 4 factorial into 4 into 3 into 2 into 1, just cancel out the even. So what are you left with? 7, 5, 3, 1 upon 4 factorial into 2 raised power 4. Same is the story here. Okay, so that's it. So now the next one is, let A be a set. Small is the number of subsets of A. So how much is it? It's 63. 63 is 20. B is the number of ordered triplets that can be formed using elements of A. Ordered triplet means B is nothing but by how many ways you can select into 3 factorial. So it's 120. C is the number of such triplets repetition is allowed. Without repetition was B. Repetition is allowed means you have 6 tries for all the cases. So it's 216 and then add them up. So 140, 356, 357. That's a very simple direct question. Okay, while selecting this question, actually I thought it should be a good question of at least some involve something related to PNC or something, but it came out to be a simple question. So and anyways, moving to the next one, again see, infinite terms of tan inverse series. So that's second question we have for tan inverse. See, for this one again, I rewrote the series as 2 by 4 because I saw that every next alternate term we have 2. So I just got 2 in every term plus tan inverse of, and see, the moment I wrote it was, if any one of you couldn't solve it, now it will be a eureka type of moment, isn't that? So tan inverse of 2 by 36. Now look at the pattern. Isn't that a very clear direct pattern, which is summation of tan inverse of 2 over what? Uh, um, 2 square, 3 square, 4 square, r plus 1 whole square. So it's summation of tan inverse of, so if I open this, 1 plus r square plus 2r. Okay, so how to get 2 here? Anyways, so r goes from 1 to infinity. So it's tan inverse of 2 upon 1 plus, okay, we got it. R plus 2 into r, whose difference is sitting in the numerator, so I can write it as tan inverse of r plus 2 minus tan inverse of r. See, here alternate terms won't get directly cancelled. There will be a gap of 1 initially. So S is, so let me do it. So when you put it as this, so tan inverse 3 minus tan inverse of 1, then plus tan inverse of 4 minus tan inverse of 2 plus tan inverse of 5 minus tan inverse of 3. So that's the first term which will start getting cancelled. So after that, every term will get cancelled. We are left with two negative terms in the beginning. So as I said, every time we'll be left with two positive terms at the end. But since the series is going till infinity, bachon, series is going till infinity. So in that case, we'll be having uh, tan inverse infinity 2 times, which is pi by 2 plus pi by 2. Okay, so according to me, it should be um, pi minus tan inverse of 2 plus tan inverse of 1, which is tan inverse of 3 upon 1 plus 6. So pi minus, so I think there's something went wrong. Tan inverse infinity infinite is pi by 2 itself. चलिए एक बार आप लोग I wish that you people check it once. Okay. um, 10 was a plus 10 a plus b upon 1 minus ab. Okay, so it doesn't make a lot of difference, no? Okay, it's 3 by 5, no? But that's not an option. None of these though is an option. चलिए एक बार आप लोग check करिएगा. I think we got it. I mean, I can't find any mistake anywhere here. Okay, so it's r plus 1 whole square if I'm not wrong. So it's 3 square, 2 square, 3 square, 4 square. Yeah, it's r plus 1 whole square. R goes from 1 to 1 is 2 by 2 square, 2, 3 square. Yeah, everything's fine, no? Tan inverse of r plus 2 minus r. Yeah, can't find a mistake. चलिए बच्चों, I will leave it to you people to check it. The minimum value of this quantity. Okay. See, how did I approach? I took a inside in the first one, so a plus 1 by a plus 3. Similarly, b plus 1 by b plus 3. They are all positive number. So that's a very simple one. And we know the most famous, the simplest form of inequality which we use here is, okay, and the equality holds when a is 1. Or here a is minus 1, then equality holds. So that means a plus 1 by a is 2, the minimum value. So that's what they have asked, the minimum value. So this is 5 into 5 into 5. So 125 by 20. So whatever we get is the answer. So again, a simple one. Prove that, okay, that's an interesting one. But for that, before even I start, I will say I couldn't get this part yet. Okay, so I'm accepting it here. I couldn't get this part. It is still, as I say, work in progress. Okay, but the way I could solve it, you people might have got maybe a better way, a simpler way, or a direct way of doing it. But the way I solved it, I just want to share it with you people. We have to prove that this is these are the roots of this polynomial equation. So I took 2n plus 1 c1 common, I mean as LCM. So the polynomial is 2n plus 1 c1 x raised power n minus 2n plus 1 c3 x raised power n minus 1 plus 2n plus 1 c5 x raised power n minus 2 minus plus minus plus till infinity, and this is equal to 0. So I just kept my focus on this. How to get this as a series expansion, or a expand, not series expansion, expansion for a binomial. Why? Because we have binomial coefficients here. Okay, so 2n plus 1 is odd, one thing. Okay, and second thing is, see, there's a gap of 2, I mean gap of 1 between two consecutive the subscript of consecutive binomial coefficients. Okay, or the coefficient of that term, but the power, the gap of the power is just of 1, so they are consecutive type of thing. How to get it? Moreover, there is alternate positive negative sign also. So first thing I started was root x. Why? Because see, root x plus 1 or root x minus 1, whatever you think. But see, if I put root x plus 1 or root x minus 1, I won't get, in that case, if I go for minus 1, you'll get the positive negative sign between any two consecutive terms. That means any two binomial coefficient, consecutive binomial coefficient. Here, the change difference of the sign, opposite sign, is not for two consecutive binomial coefficient, but there's a like for all odd binomial coefficient, alternate positive negative sign. How to generate it? So then I thought about iota, rose power 2n plus 1. Now rewrite this series, I mean open this binomial. So it is 2n plus 1 c naught x raised to the power 2n, and this is odd, okay, plus iota into 2n plus 1 c1, and when you root x raised to the power 2n, which is nothing but 1, plus iota square 2n plus 1 c2 x raised power 2n minus 1 by 2, which is odd, plus iota cube, which is minus iota 2n plus 1 c3 x raised to the power 2n minus 2 by 2 n minus 1. Okay, now look at your series and you will find that the series which we are looking here at is actually nothing but the collection of imaginary terms, imaginary part of this series, of this expansion, imaginary part. So this you can write it as some real part plus iota times. Now check out with your series बच्चों. X raised power n minus 2n plus 1 c3 x raised power n minus 1. Next one will be 2n plus 1 c5 x raised power n minus 2, and so on and so on. That's what we need. Now it's very simple. We have to just get this imaginary part. Now since we have to prove that, let's say cos square k pi by 2n plus 1 is a rule. So I just went for it general. So replace x by this. So you have cos k pi by 2n plus 1 plus iota after taking LCM k pi by 2n plus 1 whole raised to the power 2n plus 1 divided by, see, that won't make any difference. I mean, if we are going to equate it with 0 in any case, but it will be sine k pi by n plus 1 um, whole raised power n plus 1. Isn't that okay? Now collect its imaginary part. So using the Morris theorem, this will get inside and multiplied with the argument. So it's cos k pi plus iota sine k pi upon sine raised to the power 2n plus 1 k pi by 2n plus 1. Now imaginary part is this, which is always 0 for all k from 1 to n. So hence for all k from 1 to n, this is root of this equation. That's it. Okay, so that's how I could solve this question. But as I said, How to use it to get it is still a part which I have to do. So if anyone get it, you can share it with me using the comment box. Now moving to this question. This question is again, what? We'll go for the general term. General term is nothing but r square upon um, 1357. So it's 2r minus 1 into 2r plus 1. So see again the same story. So r square upon, so I will rewrite. See, we don't have any standard method, so the only thing on which I keep my focus is rewriting the general term of the series as a difference of two terms, bachcho. So I will divide and multiply by 4, add and subtract 1. So it's 1 by 4 times summation of 1. R goes from where? 1 till 500, bachcho, and then minus plus rather 1 by 4 times summation of 1 by 2r minus 1 into 2r plus 1, which we can easily rewrite it as, so 1 by 4 into 500 number of terms, summation of 1 is number of terms, okay, plus 1 by 4 times summation over 1 by 2r minus 1 by 2r plus 1, and I think it will be into 2 also to balance it. Now you open it and then you can simplify it to get the answer here. Okay, I think it's fine. Now moving to the 16th one, a sequence of real numbers is such that, see here what I did was simply I just went for writing a2. A2 is nothing but mod of 1. Now the mod of a2 is 1. Okay, so that means A2 is possible values are minus 1 and 1. Then I thought, okay, let me try to get A3. Mod A3. Mod A3 is mod of A2 plus 1. So if I go for mod of A2, A2 as minus 1 is 0. So one of the possible values 0. Similarly, mod A3 can be 2. So other possible value of A3 can be minus 2. So the possible values are minus 2, 0, 2. Likewise, if you go for A4, keeping different values, okay, so it will be minus 3, minus 1, 1, and 3. Now, see, we have to find the mean here. Okay, so is that restricted? I mean, the point is, see, if I go for the highest, largest values, like for A4 is 3, A3 is 2, A1 is 1, A2 is 1. Okay, then we get something like n into n plus 1 by n into n minus 1 by 2 by n. So it's like n minus 1 by 2 and plus 1 by 2. Similarly, if we go to the negative scheme, extreme, it can be minus times and minus 1 by 2 or minus times and plus 1 by 2. So is it restrict, or we can go for like alternate as 0, and there are so many combinations here. So can we restrict it like it is always less than this, it is always greater than 1? No, it can be either positive, it can be the negative. So hence the answer should be, the most appropriate answer in that case should be none of these. Okay, because a single correct question. Now moving to the last question here, we have to again prove it, and again this is the same question where we have to break it as a difference of two terms. Or the only thing is, why did I take it? Because it took some time for me to break it as a difference of two terms. Okay, so what I did that day was, I did something. Again, I have to think. Okay. So tan inverse of, I divided by 2. Half. Okay. And then I rewrote it as, let me try. R raised to 4 plus 1 by 4 plus R square minus R square plus 1 by 4. Right. See, I just wanted to get a perfect square so that I can see. The point was, the way I thought was, the difference till you have r raised to power 4, and even if you break it into two factors r squared, the difference won't be r. So I need the factor where we have r, then only the difference can have r, a linear term. So for that I just converted it to a perfect square, and that r square subtracted r square. I think it will work. That's what I did that day, I believe. So tan was, I missed tan was there, doesn't matter. Okay, so it will be r upon 1 by 4 plus r square plus half whole square minus r square. Okay, so what can we write for this is, so S is summation R goes from 1 to whatever, and tan inverse of R over. So see, we still don't have 1 here, but I'm just keeping my focus here. So plus R square plus R plus half, R square minus R plus half. Okay. Now I will take LCM. So you could have said that, okay, in that case, I would have multiplied. See, that's how I thought. Okay, so I'm just writing the steps in the way I thought. Okay, so it's 2 into R square plus R plus half into 2 into R square minus R plus half. And we got it. Okay, so this is summation tan inverse of, fine. So 2R square plus 2R plus 1. I'm taking this 2 inside, taking this 2 inside, minus 2R square minus R plus. That's it. Upon 1 plus this into this. Okay, so it's simply summation tan inverse of 2R square plus 2R plus 1 minus tan inverse of 2R square minus 2R minus 2R, yeah, plus 1. Now see, before I conclude here, I will just check, and that's what I always do before saying that now we can finish it off. See, putting the values of R and check that alternate terms are getting cancelled or not. So it's 5 minus tan inverse of 1. So you go for 2. So 4, 2, 8, 12, 13, I believe. Minus tan inverse of 8 minus 4, 5. That's it. Once it starts there, then let's see for 3 also. 3 square is here. It should be here. So 18 minus 6, 12. Yeah, right. It will get cancelled. So as I say, first term negative, last term should be positive term, and then you can write it. And the last term you will get from this positive from here. So actually it will be tan inverse of 2n square plus 2n plus 1. Okay, minus tan inverse of 1, and then again applying tan inverse, minus tan inverse, we will get it. Okay, we definitely get it. So that's it. So that's it for today. The only thing left is this, which if anyone get, do share it with me in the comment box, or I will also keep trying it. If something is right, then I will also try to share it with you people. Okay, so let's end it. We'll be coming up with maybe the next one should be vector and 3D bachcho. Okay, so the next one will be vector and 3D. Chaliye, till then, bye and best wishes to all of you bachcho.